Hi everyone, welcome to the Running NoSQL on Amazon Web Services session. We're happy that you guys made it, and let's get started. So first of all, let's decide together what NoSQL means and why we're here. So what makes a NoSQL database different from, for example, a relational database or some other kind of data store? The most important characteristic is probably that it's schemaless, at least as far as the definition goes. So what does that actually mean? Well, if you think of DynamoDB, for example, every item can have an arbitrary number of attributes, or to use another term, columns. So you don't have to follow a strict schema, a table schema, or whatever the case may be for a NoSQL database. Another characteristic, at least for the NoSQL data stores that we're going to talk about today, is tunable consistency. And this is really important for distributed systems or very large-scale data stores like the ones we're talking about today, because often you have to make trade-offs. And you have to decide, do I want performance? Do I want durability? And you can tune and tweak your database to match the characteristics that you want for your application. It's not always the case. It was me. I'll give you an example. Say you need a very wide distribution of data, and having the data available, extremely durable, tons of replication is the most important characteristic of your database. You're potentially willing to sacrifice a little consistency, like a Facebook feed, for example. If you have the feed going by, it's not important that every single one of your friends sees the same feed state. It just has to be eventually consistent, and this would be a good example of an eventually consistently tuned NoSQL database. Other times, consistency and accuracy for every person who's looking at the data record is extremely important. So the ability to tune that, depending on the feature, is critical and is one of the things that you can do with a lot of the NoSQL data stores like the ones we're talking about today. Of course, distributed, you need to be able to have redundancy, to replicate, to distribute, not only across a wide geographical area, but across a lot of VMs from a redundancy perspective. And highly available, it kind of goes along with distributed. You want the data to be durable, you want it to be replicated across multiple facilities, not just multiple servers, and you need a database that can work with that and not suffer performance when it is highly available. So today we're here to talk about 3 of many NoSQL solutions that you can run on AWS. One great thing about AWS is that you have a lot of flexible options. We have managed services like RDS and now Aurora, how cool is that, and DynamoDB. But you can also run whatever database you want on EC2. And this is important because not every database is the same, and we all have different applications and different needs, and different databases suit and fit those needs, or perhaps they can be tuned and tweaked in ways that match your application or your business. So you have the choice. Today we're going to talk about MongoDB, Cassandra, and Couchbase, 3 very popular databases, all of which you can use on EC2. So at a high level, how do you get started with these databases? You can use the AWS Marketplace to provision AMIs, Amazon Machine Images, to deploy these solutions on EC2. In the case of DataStax or Cassandra, you can use their community AMI to deploy it on EC2. They're not yet on the AWS Marketplace. But the Marketplace is a great place to start for these databases and more. And essentially, they give you a bundled image that you can deploy to EC2 and have the software pre-installed and ready to use. Before we jump into the specifics of each NoSQL database engine that we're going to talk about today, we wanted to discuss some best practices. So first of all, NoSQL databases on EC2 tend to be memory and I/O bound rather than CPU bound. So this is really important when you go to pick your EC2 instances. So we have some great new instances that have come out roughly over the last year or two, notably the I2, the R3, and the M3. The I2 will give you really high I/O, and it's kind of the dirty secret we're going to talk about for a lot of NoSQL databases, that the Achilles heel in terms of performance, even though a lot of them do a lot of stuff in memory, is actually often storage. Because even though you're operating in memory, you still have to persist the data to disk. And we'll see this repeated later with the other sessions. And so that action of persisting data to disk can become the bottleneck. So high-performance storage is an extremely important characteristic of any high-performing NoSQL database. So that's why an I2 is great. It's meant for really high-performant SSD operations, really fast storage attached to these instances. Some databases benefit from more memory. That's why we have R3 instances. And lastly, if you aren't really sure, or if you're looking at your metrics and there's no clear winner in terms of how you're being bound from a performance perspective, we offer the M3 class of instance types for those. When you're thinking of storage, again, you have choice. We have Amazon Elastic Block Storage, EBS, which is persistent storage separate from your instance. And in a lot of cases, this is the right choice. And if you were to read the white papers on Couchbase or MongoDB or others from years past, you would have seen the default was to go with EBS. And so why do we have instance storage up there? It's because times are changing, and NoSQL databases can often be tuned to have a high level of replication, and EBS and that persistence that comes with elastic block storage becomes less and less important in some circumstances. So you can still use EBS with your NoSQL databases, but for the most part, what we're going to be talking about today is how to use ephemeral storage, directly attached instance storage with NoSQL. And with the proper backups and with proper replication, it becomes the preferred choice in most cases for NoSQL deployments on EC2. You can get the best level or a good level of durability that meets your SLAs and your RTOs and RPOs and other acronyms, while at the same time benefiting from the extremely high IOPS of that ephemeral storage. And by high, I mean hundreds of thousands of IOPS. So just remember, if you're using instance storage, what's the golden rule? When I stop my server, my storage goes away. So always repeat this to yourself over and over again. Backup, replicate, and all of the systems that we're talking about today give you the ability to replicate and to back up so that you can use instance storage with confidence. You should always design for failure. Things are going to fail, things are going to die, and your system should not ever suffer in terms of performance or availability because of one node that happens to go down. Some other characteristics that can help you speed things up. On Linux, you can optimize the ulimit, the read ahead, and the TCP keep alive. These are distributed systems, and so these kernel tuning parameters and other optimizations you can do help the networking and the storage performance because the performance is also inter-node. There's a lot of bits flying around between these distributed systems, and it's important that your cluster that is running your NoSQL data store is optimized from that perspective as well. You can stripe multiple volumes, but just be careful with striping, because if you stripe volumes, it becomes harder to snapshot. If you've ever tried to take a snapshot of a RAID array, for example, it's not exactly straightforward necessarily. So if you are going to stripe volumes for performance or for aggregate storage reasons, just think carefully about your backup strategy and your snapshot strategy as well. We want to save you money. That's one of the biggest parts of my job, and it's what makes Amazon pretty unique in the market. Is I usually walk into companies and I say, here I am not to sell, but to sort of anti-sell, to help you reduce your costs. And one of the ways that we help you reduce your costs is to help make things elastic and to really adopt a pay-as-you-go model. And from a NoSQL perspective, you want to size appropriately, and if possible, be able to change the size as required. Things like using reserved instances and a mix of on-demand and reserved is a great way to lower your costs. A reserved instance is you put a little bit of money down, and then you get a lower hourly rate. And so if you have a core of reserved instances that you know will always be there, and then augment that with on-demand, it's a great way to keep your costs down. With distributed systems and NoSQL in particular, one kind of hidden cost is data transfer. And we mentioned this, it's also a performance characteristic. It's a distributed system, so there's a lot of inter-node traffic going on, inter-AZ traffic in some cases if you're multi-AZ. So to keep your data transfer costs down, think carefully about how you replicate, and we'll also discuss this later. Because if you have a multi-AZ deployment, say 3 availability zones, and you have replicas across 3 availability zones, there is a charge for inter-AZ traffic. So think carefully about what you're replicating, what your replica counts are, and you can save a lot of money. Not all data is created equal. For example, session information for a website is kind of low value. You don't need to replicate that with a factor of 4. But maybe core user information is valuable and very important. You don't want to lose it, so you have a higher replica count. So parse your data out and adjust replication accordingly. And the systems, again, we discussed today, allow you to prioritize from a replica perspective different sets of the data. So first, I'm going to pass it to my colleague Rahul, and he's going to tell you about best practices for running MongoDB on EC2.
Thank you, Matt. So let's get started with MongoDB on EC2. MongoDB is a general-purpose database. You can use it for a variety of use cases, such as gaming, mobile analytics, storing content management system, and such. When I say MongoDB is a document database, you can think of something like a MySQL, but instead of tables, you really have something like JSON-like objects, which defines your database. And finally, MongoDB is actually free and open source. It has a great community support. It has drivers available for multiple programming languages or application frameworks which you can use. MongoDB also comes in Enterprise Edition, which adds certain features to the current, the free and open source version. And we'll talk about that, what are the features throughout this slide as we go along on this talk. So first up with MongoDB, let's talk about what exactly is a JSON document and what are dynamic schemas or schemaless, which Matt referred to earlier. In MongoDB, you store data, something as called collections. A collection has one or more documents. And each document is basically a JSON which has fields inside it. And those fields basically define your database. Think of it something like a collection being something similar to a table, document being something similar to a row, and field inside the document being something similar to a column in a relational database. But the difference here being that you don't have to define the schema, you don't have to define the fields, the values. Your application can pretty much write a document in any schema it prefers. In general practice, it's always good to have a collection which has the large, homogeneous documents stored together in a collection, but again, it's not required. Now, MongoDB also can maintain multiple copies of data by a feature called replication. That replication can provide you scale-out reads. It can also provide you a high availability for your system, and we'll talk about that as we go along. With sharding, you can basically scale out a single server, in case you are bottlenecked by a single server deployment in terms of memory, in terms of I/O. You can use sharding to basically partition your data across multiple servers and address that scalability or address that limit of a single server deployment. With aggregation framework, your queries the results can be aggregated, something similar to a SQL group by statement. You can run your count, sum on your results before they're returned back to you. And with MapReduce framework on MongoDB, you can which is expressed in JavaScript, you can write complex data processing which runs on the MongoDB nodes itself and before the data is returned back to you. So it can take advantage of the data node processing. Finally, MongoDB is not limited to only key value operations, simple key value operations, but you can take advantage of rich queries. It has support for a variety of indexes, such as unique value indexes, TTL indexes, time to live indexes, sparse indexes, array indexes, geospatial indexes, and these all can help you basically take more value out of your data in MongoDB. So let's look at it. Before we move further, I want to talk about MMS, which stands for MongoDB Management Services. The way MongoDB Management Services work is basically it's an agent which runs on your MongoDB server, and the agent talks back to MMS. With MMS, you can basically provision a MongoDB cluster at any scale. You can upgrade your MongoDB instance without taking any in a few clicks without taking any downtime, or you can even scale out, as I mentioned about sharding. It also takes a continuous backup of your MongoDB deployment, and using that backup, you can actually restore to any point in time securely, and we'll talk about that as we go along. Not only that, MMS can also track over 100 plus key metrics from a MongoDB server, and you can use those metrics to create alerts or other such insights into your MongoDB deployments, so you can take actions before your system actually degrades based on those metrics. We'll talk about MMS throughout as you go along the slides and how does MMS fit in there. So let's take about how does MongoDB, a single instance of a MongoDB process, which is basically the Mongo database process, works. It works by something called memory map files. Memory map files are basically something from a disk block is basically mapped as a block in the memory, and all your reads and writes are basically done to the memory. And that's the way MongoDB can provide you very easy and fast access to your data set. But with that model, it's always important to ensure that your working set is basically your data which has to reside in the memory for your normal MongoDB or day-to-day operations. It has to fit in the memory. If it doesn't fit in the memory, what's going to happen that your system will need to read the block from the disk back in the memory, and that will lead to something called a page fault. So you need to ensure that you can fit your working set in the memory. If you already have a MongoDB server or Mongo database running today, you can run basically a server status command, and the server status command can help you understand your working set a little better. In case you don't have it, you can use something like a simple heuristics to figure out how much data your applications work with. Again, you can monitor the MongoDB. The idea will be that to limit the page faults which happens on your MongoDB instance, because those are symptoms of a MongoDB behaving poorly. If your queries are so a lot of queries are being queued, that's again a symptom which might lead to page fault later. So you want to ensure that those two metrics you're keeping track, at least in MMS, to understand that your system is working in a perfect manner or working in an optimal manner. So moving on we talked about a single server of MongoDB. How does it work? Now let's talk about what you're going to do to provide HA or high availability for a MongoDB instance. As I mentioned earlier, MongoDB can maintain multiple copies of your data set by something called a replica or replications. In replication, one of your node is primary. All your reads and writes are done to the primary. And the rest of the nodes, which are called secondaries, they basically replicate from their primary using something called oplog. Oplog is basically an ordered set of idempotent operations, which a secondaries basically reapply on when they get the data set on every read or write from primary. And the secondaries can also provide you a little scale-out read In case you want to scale out your read, you can also use secondaries to do a read. But in that case, your application has to deal with eventually consistency. The way the MongoDB provides consistency or allows you to handle consistency is something called write concerns. What write concerns do by default is write concerns tells your application saying that there was no network error or there was no duplicate key error. But you can change your write concerns such that you can say that when I do a write to a MongoDB, do my write across certain secondaries, do my writes across majority of secondaries, or do my writes across all of the secondaries, in which case you can use any secondary to read your data, which will provide you a strong, consistent read. In case of a failure, what really happens, let's say a primary goes down, one of the secondaries is automatically based on certain configurations you can choose, you can provide them a priority. Based on that priority, a secondary is automatically elected to a primary without any manual intervention. So application can, or MongoDB can provide you HA for your critical deployments in production. So when you deploy a replica set on AWS, you don't really have to stick to having the same instance for both primaries and secondaries. You can look into different factors on how you can deploy your primaries and secondaries. For instance, let's say that you use PIOps EBS for your primaries. What you can do is for secondaries, you can create 2 GP2 volumes of around 5,000, half the size, so it can provide you with the same I/O characteristic as of the primary. Again, the idea is that since oplog is the one process by which MongoDB replicates from primary to secondaries and it's done asynchronously, you have to ensure that there's no replication lag between them. Replication lag as in the time it takes, by the time you do a write on the primary, by the time it takes for it to appear on the secondary. So this is one of the monitor you want to measure carefully. In case your replication lag becomes excessive, what could happen is that the secondaries could become ineligible to become promoted to a primary, or your consistency might degrade way further based on the lag itself. This is one of the things you want to monitor with the MMS in case of a replica cluster or replica sets, your application lag, how far it is between a primary and secondary. MongoDB also is coming out something called pluggable storage, which is the new in 2.8 release. Hopefully that comes out in January of 2015. And that will basically allow you to change the default from the memory map files to something maybe like RockDB or other pluggable storage engines you can think of. So we talked about a single instance. We talked about HA. Now talk about scalability, that in case you're bottlenecked by a single server instance, how do you going to, let's say you're bottlenecked by RAM or you're bottlenecked by storage I/O, how do you really scale out? That's done by something called sharding. In sharding, basically what you do is you partition your data across multiple shards. Each of the shard here could be a single server, or it could be a replica set itself. And in production, we recommend that you use replica sets to deploy each shard. Now, in the shard, there are multiple ways of architecture, the multiple of sharding mechanisms you can choose. You can choose something like range-based sharding. Range-based sharding, basically, based on range, you're distributing your data across shards. You can choose something as a hash, or you can choose something as a tag-based sharding. In tag-based sharding, for example, if you're deploying a shard across multiple AWS region, you can tag your shards such that the application has the data closest related to that region itself, so it's not doing cross-region reads much often. With shard, also what happens that your application doesn't have to deal with the complexity of talking to a shard on how to partition the data. There's something called a query router. So your application basically talks to a query router, and the query router determines which shard the data is in there. So you can add as many shards as you want, but your application code will still remain the same because it's actually talking to a middleman called query router, which is managed by the MongoDB deployment itself, rather than changing the code in application every time you add a shard. So we have talked about we talked about high availability, you talked about scalability. But in case of a DR scenario, how do you really cope up with that kind of scenario? So there are 3 ways, there are 3 different methods you can look at in the terms of backup and recovery. You can really choose secondary. You can look at using a secondary as a backup, but that's really not a recommended way to back up your data set. In case of DR, the secondary itself might not be available. MongoDB also has tools such as MongoDump and Restore. MongoDump, basically what it does is it creates a backup of your documents or your database in MongoDB in something called BSON files. And you can use Mongo Restore to reload that BSON files back in your Mongo database process. It doesn't work for a very large data sets. And again, you have to take care of various features. For example, if you're taking a backup, you have to ensure that general is enabled. Generaling is basically a durability by which MongoDB provides durability for your writes. In case your general is not enabled, you're taking a Mongo backup, what could happen? The backup might be inconsistent. If you're taking a backup of a sharded cluster, you have to ensure that your your config servers are not up that point in time because there could be some chunk migration happening, and that again could make your data inconsistent. So these are things you have to keep in mind while taking a backup. Or what you could do is, as I mentioned earlier, is use MMS to take that backups. What MMS does, we'll look at that in the next slide. The way the MMS works is basically similar to what you have in secondary. That MMS takes your continuous backup of your op logs, and since it uses only op logs to create a backups, the performance impact on your cluster is similar to having a additional secondary in your replica sets. And since it takes a continuous backup of your op log, which is again an idempotent set of order operations, it can basically restore to any point in time. To restore, what you have to do is basically use a two-factor authentication to download the files from MMS. You take that files, you distribute the files on your MongoDB instances or MongoDB servers and restart your MongoDB process and actually have a backup, or you have a new MongoDB process running from that point in time onwards. Moving on, so now it's always important to monitor deployment because you cannot optimize what you cannot measure. So it's always important to measure your MongoDB instances so you have good insights into what is really happening with your. So again, the choices being first with MMS. MMS can track, as I mentioned, that 100+ key metrics such as CPU utilization, your RAM, your server status, or even from your MongoDB itself, such as number of concurrent connections, number of read writes, how many queues what's the length of a queue, and such metrics. What happens that such metrics are reported over to MMS agent in real time, and where they are aggregated, and you can visualize them in real time on a browser or something like that to get a key insight into your MongoDB deployments. You can even create alerts based on certain metrics or ranges of metrics, saying that, tell me that if a replication is going beyond certain status, notify me via email or SNS so I can take action before my deployment actually degrades. Now, if you're not a MongoDB enterprise customer, in which case you can actually deploy the MMS agent within your environment itself. Or if for some reason you don't want to send over the data over to MMS, which is offered by MongoDB as a service, you could also create such an environment using CloudWatch and SNS alerts. In that case, you have to use something like custom metrics to generate those metrics by using your own commands and send those to CloudWatch and create SNS alerts based on them. There are other tools also, such as Mongo-perf, not to be confused with the Mongo-perf here. Mongo-perf is used to measure the storage I/O of your server. Mongo-perf is used to measure the MongoDB deployment itself, in terms of number of concurrent connections, how does it behave, and stuff like that. There's something called mtools also, which can help you visualize your MongoDB log files. So you can take, for example, MongoD, MongoS log files, and run them through mtools, which will help you parse, filter, and visualize those log files to understand better in how the processes are behaving. But again, very important to measure your system. As I mentioned earlier, that if you cannot measure what your system is behaving, there's no way you can optimize it. MMS also uses MongoDB profilers within the MongoDB deployment, so you can actually get insight into your queries, which are running also in that system. So with respect to security, MongoDB offers something called custom roles, and privileges. So you can assign users and apps custom roles and privileges, so they only have those privileges necessary for them to do their task. It also has something called field level reduction, in which you can basically use a trusted middleware to control access to individual fields within the document itself. MongoDB also has built-in authentication, or it can provide authentication via external authentication, such as Kerberos, LDAP, X509 certificate, or even Active Directory. With MongoDB Enterprise, you can also get a SSL. So your data is basically encrypted over the wire. So when the clients are connecting to a MongoDB server, the connection is encrypted. Or you can actually use the free, you can rebuild yourself using the MongoDB free open source version by adding the SSL component in there. With inbuilt auditing capabilities, you can use it to meet your governance and compliance needs. So figure out who accessed the database, what changes was done, what was happening in the queries. So we talked about a lot of features of MongoDB, and just to put everything back in perspective, this is a deployment of MongoDB in a production kind of scale. So you have one shard, you have multiple shards. Each shard is a replica set, basically, which has one or more servers. And you have applications which are talking to query routers. There will be multiple query routers in a production deployment. But this is what holistically it looks like when you deploy MongoDB on AWS cloud. Now, but how would you really deploy this? How would you really easily deploy such architecture on the cloud? So with MMS, there's also support for you to deploy such a pattern on the cloud using few clicks. In the next slide, you're going to see a small video, maybe a minute video. The video talks about how MMS is deploying a sharded cluster onto AWS within few clicks. And I'm just going to leave the video. Hopefully, that plays in the next slide. So you can see on the right-hand side how the video is talking about how somebody is actually using MMS to deploy a sharded cluster on AWS. It has support for VPC. It has support for doing a multi-AZ deployment. It even optimizes your choice of your instances, or which instances you're choosing to deploy your server on AWS. And with that, I would have, like to invite John to talk about Cassandra next. Okay. But I will encourage you guys to go ahead and check MMS at mms.mongodb.com.
We'll be taking questions afterwards. You want to let this finish?
Yeah.
Yep.
Or you can
go for it.
You can go ahead.
Shall I go ahead?
Yeah.
All right. Cassandra, at speed. All right. Just a brief overview of Cassandra, which is a distributed key value store. It's not a document store, key values. It's locally managed storage. All right. Each node in there is independent, so you have a great fault tolerance, no single point of failure in a cluster. It's quite scalable, and you can tune your consistency easily. So it's beyond that, it falls into the other characteristics of NoSQL. That means you're not going to get support for joins. You're not going to get subqueries. Reads and writes can go to any node in the cluster. Any node can act as a query coordinator, routing requests to the nodes that actually are meant to store data for a particular request. And there's a peer-to-peer protocol they call Gossip that exchanges information about the state and the location among the nodes. In terms of storage, for data, we recommend that you use ephemeral storage for the reasons that Matt described. You're going to get better performance from that. It's that shared nothing architecture again, so why fight that, really? The recommended practice is to choose SSD-backed instances. You can use RAID 0 if you want to. You don't have to. And you can use EBS storage, but we recommend that you do that simply for targets for your snapshots. Use it as your part of your backup strategy. All right. In terms of data consistency, it's tunable. You can choose how consistent each read or write request can be. There's great granularity there. You can imagine that if you have a massive cluster, you can run into consistency issues periodically. There are tools within the cluster that make this quite robust. There's a read repair tool to bring replicas up to date. There's this concept of a hinted handoff where if for whatever reason a query coordinator tries to reach out to a node that's not available, it can locally store writes and then pass it to the unreachable node when that becomes available again. And then there's a node repair tool that can make data consistent on a node. And it's sort of applied in that order, I think. In terms of availability and scalability, clusters can span Amazon availability zones and Amazon regions. Right? The nodes between them use this Gossip protocol that I told you about earlier to learn the status of other nodes in the cluster. And the data is replicated to multiple machines, and each is able to read and write independently. So if you lose a replica, you still have access to that same data. You can design a cluster, as I mentioned, across availability zones and regions. That gives you tremendous robustness in your cluster, as you can imagine. The recommended practice is to use this software called there is a software called a snitch that is used to describe the network topology so that requests are routed efficiently. There are two specific snitches that are written to run on EC2. One, the choice is really, are you going multi-region or not? But choose the right one and don't try and force it, or look carefully if you think you need to write your own. And if you're translating from the Cassandra documentation to ours, where they talk about racks, think availability zones. Where they talk about data centers, think regions. All right. There's a concept of a virtual node in Cassandra. What that does is it breaks down the granularity of the range of a key space that's going to be located on a particular node. This is great for recovering nodes, all right? That means that if you need to bring a node back up, catch a node up, you're pulling data from across many nodes, so you're not going to see hotspots when you're doing this recovery. That'll also speed the rate at which nodes are built because of the way the data is shipped. For backup and recovery, I mentioned earlier that You can use EBS here. What you do is create a snapshot of all the files on your data disk. You can back up the entire database. You can back up just tables. You can do incremental snapshots after you've taken a full initial snapshot. And you can copy these snapshots, and you should copy these snapshots to Amazon S3. And there are tools that exist that can help you with this. DataStax has tools for this. Netflix has a tool called Priam on their GitHub that I think is also useful. In terms of monitoring, we recommend you use either CloudWatch, or if you've got the DataStax license, use their tools if you like. Pay attention to queues, queue length, the I/O statistics, both the throughput and latency, your memory utilization, and your network activity. In terms of security, you can go out and create users as you would ordinarily in a database. You can grant and revoke privileges as one typically does. And we recommend you use SSL encryption to protect data in transit. And that can go from client to node and from node to node. And you can decide whether it's going to be all nodes or just between racks or just between data centers. In terms of the architecture, you can stand these things up, as I mentioned, in separate regions. And we've got joint customers that have done this, where they've lost an entire access to a region for whatever reason, and the cluster will be up and running in the other region quite robustly with minimal interruption for the application behind it. So that is Cassandra at speed. And did I make up enough time?
All right, awesome. So Couchbase, I'm wearing my Couchbase red today. Actually, I was told earlier that it's cranberry, but we'll pretend it's red. Anyway, Couchbase is the third and final NoSQL data store that we're going to talk about today. I love Couchbase. It's a great, flexible NoSQL data store. It has a strong history, and it works really well on EC2 and AWS. Couchbase comes in a few flavors. There's Couchbase Server, which many of you will already be familiar with. But there's also the new Couchbase mobile initiative, specifically Couchbase Lite, which is a lightweight database that can actually reside on mobile devices or other types of smaller devices. And there's something called the Sync Gateway that can synchronize data from Couchbase Lite to Couchbase Server. So it's a really good choice if you're doing mobile development or any kind of development where you have that kind of synchronization going on between remote devices and a central database. It's both a key value and a document store. So you can use it like a key value store like Cassandra, but also like a document store. You can store documents, like JSON documents, for example, up to 20 megabytes in a Couchbase database. It's distributed in a shared nothing architecture, so it scales really well, it distributes really well, it handles, it's fault tolerant, and if you architect it correctly, just like John and Rahul were describing, you can lose nodes, you can recover from failure, and you can reach your RTO, your RPOs for availability and durability. You can tune your consistency, and importantly, it has a Memcached compatible API. And this sort of is attractive to a lot of people because many of you have applications that have been written against the Memcache API. No need to change them. Couchbase can still understand. You don't have to go rip apart that code. So let's dig in. I'm going to try and keep it specific to AWS, so I'm not going to cover all of Couchbase, but what do you have to care about if you're running this on AWS? So first of all, again, just to sort of reiterate the point, storage is often the bottleneck. In most cases, certainly with Couchbase, it can become the bottleneck because the writes, any kind of operations you do, will eventually be persisted to disk. So just always keep this in mind, that the storage tier is extremely important from a performance perspective. I mean, that's why we're sitting here recommending ephemeral or instant storage and the fast SSDs associated with the new instance types and the direct attached SSDs that they have. In Couchbase 3.0, there's some great new features that allow you to prioritize disk I/O. And also, Couchbase has this concept of buckets, kind of logical groupings of data, and you can prioritize I/O for the disk I/O on a per bucket basis. So that allows you to, like I was saying earlier, you can prioritize replica count per data set. You can take your virtual buckets, and prioritize not only how many replicas you have of that data, but also how much I/O, how much performance you should allocate to that data. Because again, not all data is equal. A web session is not as valuable as the user profile itself, for example. And when you're calculating storage, how much storage you need, remember, it's not just like storage. It's how much storage you have, how many times you're replicating. And if you have a replica count of 1, that's 2 copies. And then there's some metadata associated with that. And as your data grows, it's not going to be a simple addition, a simple sum of how many replicas you have. There's other factors to consider. And dig deep into the Couchbase documentation to get the full volume count. Memory is really important. Couchbase tries to do as much as possible in memory, and we'll talk about some things like DCP and some new features in a second that take even more advantage of memory than previous versions. But when you're calculating your memory requirements, this is a pretty crude addition, but it serves as a good baseline for starting. So take your working set, and this is an important distinction. Not your whole data set, but the data you actually are operating with and operating on. That is your working set. And that is what should represent how much memory you're calculating. Because again, you may have this huge database, but you're only leveraging a subset of that data on a regular basis. That is your working set. Then take the server image, and by that I mean the amount of memory that is consumed by running Couchbase itself. People often forget about that and miscalculate it. There's a lot of memory required to run Couchbase at scale. And then metadata associated, how much replication you're doing, and other activities. This stuff consumes memory. So be a little nuanced about your memory requirements when you're adding it up and when you're trying to decide what instance to pick. And importantly, monitor. We're going to get to this later, but you can do all the math you want, and then there's the real world. So this is why we're going to tell you about some monitoring tools that help you get the real numbers so you can right-size your instances. And again, remember, with EC2 and AWS, you can always change, so you're not locked in. If you go with an I2 whatever, and you want to switch to an R3 or an 8XL, that's cool. It's not going to affect things. You can only pay for what you use and then replace it with another instance type as your business grows or as your profile and your requirements change. There's some new features in Couchbase 3, notably tunable memory and a shared thread pool. Long story short, you can have more efficient memory usage, less memory, and more efficient thread sharing. It has a thread pool that it can share across processes, making for faster operations. Couchbase is designed, it's always been pretty strong in HA and the ability to scale seamlessly, and it's getting better and better with time and faster in its ability to scale and recover quickly. So each Couchbase bucket, remember I was talking about buckets, they're logical groupings of data, has its own replica configuration. How much do you want to replicate the data in that bucket? And also authentication. Who should have access to that data? So you can partition your data from both a security, performance, and replica durability perspective, which is really powerful. So we recommend a minimum of 2 replicas, obviously. You want to have more than 1 copy of your data if it's important. But again, think about having non-replicated, single replica, or like a 0 replica data, where you just have 1 copy of it for low-value stuff that may be a version of data you have elsewhere that you can always get back in that form quickly. So again, you don't have to replicate everything. And there's some hidden costs. When you replicate, data moves around, and there can be some data transfer charges and other things associated with replication. So replicate carefully. Just like what John was saying with Cassandra, the concept of a rack when you're reading the documentation in Couchbase, that refers to really an availability zone. And likewise, when they say data center, they really mean AWS region from our perspective. So this new feature called rack awareness is a way to distribute your data properly across multiple availability zones. And it's a great way to leverage, to do multi-AZ with Couchbase and actually have your data distributed properly across those multiple availability zones. Another great feature if you are replicating data to and from on-premises, or if you're replicating across regions potentially, if you have a really large or really global distribution, is cross-data center replication, XDCR. And if this was written in an Amazon way, it would be cross-regional replication, or cross on-premises, if you will. And that's one powerful feature of a lot of these data stores is you're not limited. You can have a hybrid workflow where you're replicating from, say, on-premises or somewhere else where you have data, or across regions if you need that level of super availability or globalization. There's some new features in Couchbase 3.0, notably database change protocol. It's a streaming data protocol that doesn't have to persist the data to disk first. So it operates entirely in memory, so the changes means that you can replicate the changes faster. And when you replicate changes faster, there's less chance for data loss and higher performance. So DCP is a great new addition in Couchbase 3. And pause and resume. This is cool if you have a maintenance window and you want to pause the replication between, for example, on-premises or another region. You can hit pause, hit resume. It takes care of all the muck for you. So backups, especially if you're using instance storage, the direct attached stores, the SSDs, it's really important that you not only have appropriate replica counts, but that you also take backups and snapshots. And generally speaking, at Amazon, we believe in the concept of replication over backups, but backups are still important. You should replicate enough, but still take a backup. There's some tools you can use, CB backup, and really it boils down to 2 high-level patterns. One pattern, which is similar to what Rahul was saying, is where you attach a persistent volume, an EBS volume, use CB backup to write to that EBS volume and then take an EBS snapshot, which takes a snapshot to S3. The other way of doing this, if you're using ephemeral storage, is again to use CB backup and write to your ephemeral storage, and then actually use the command line tool or API to push that data into S3. And the difference is you're in a little more control there. With EBS, you can actually see the EBS snapshots, whereas if you do it yourself with S3, then you can manipulate the snapshot and perhaps push them to other data stores later on. Monitor, monitor, monitor. Everything I'm saying today may or may not be true. You have your own reality. So there's some great, Couchbase has actually always been really strong, both from a UI perspective and just all the monitoring tools that you have at your disposal. And it gets even stronger when you marry it with CloudWatch. CloudWatch has this concept of custom metrics where you can surface sort of outside data through CloudWatch. So why not take some of that Couchbase data from its strong monitoring tools and surface it through CloudWatch, and then you can act on those data, set alerts, et cetera, and vice versa. CloudWatch gives you that hypervisor level of monitoring, and then marry that with the server level, the Couchbase level metrics. Use both. For security, security is extremely important. New in Couchbase 2.5, about a year ago, you have cross data center replication. You can do it over SSLs. That's important for interregional, which is going over the internet, for example. You want to encrypt that. So just a tick box on your config, maybe a little bit more than that, and you can have SSL encrypted cross-regional replication or replication to and from on-premises. Also, if you're really, really concerned about privacy, you can leverage tools like Direct Connect for a private line between your on-premises facility that you may be replicating to. So that's a good thing. And then we also have the VPC VPN that allows you to have a really easy-to-use IPsec tunnel through your VGW of your VPC. You can leverage that, again, for replication. All the interfaces in Couchbase 3.0, the management interfaces I was talking about, are now available over HTTPS. So the access to the management interfaces, the monitoring interfaces, et cetera, are also SSL encrypted now. At a high level, this is kind of what it looks like on AWS, and you're probably starting to see some common themes here, but using rack awareness to properly distribute across multiple availability zones, and using XDCR to replicate across regions or on-premises, and you can have a truly global, fully distributed, high available Couchbase architecture. The cool thing about everything that we've discussed today is you don't have to, I'm sure some of you are going to ask us outside, which one's the best? And there's no answer. They all have a place, they all have applications, and with AWS, you can go to the marketplace, you can download the software, you can install it yourself on EC2, and just for a few cents, potentially a few bucks, you can try all of these and compare it yourself. So we encourage all of you to, use your free tier or spend that 26 cents, give it a shot, monitor, and let us know what you prefer, and we'd be happy to help you get it set up and running and optimal. So thanks for your time today, and we look forward to working with you to build out EC2 with NoSQL. Thank you.